Hello, welcome to my Tech Fun, to one of those videos where I'm presenting my test equipment. And I bought this to be able to do some stronger compression tests. And in this video I will just prepare, assemble it and do some plans for my future testings. This is 1-ton Arbor press by Vevor, and this is the pressure sensor, also with the maximum capability of 1 ton, together with this meter and gauge. The press cost me $80, I bought it on the AliExpress, and also from the AliExpress this cost me $190. So this video is not sponsored by any of these companies, but this channel has its own sponsor, that's the Polymaker. I don't have the budget to buy any filament I want to test, they are supporting my research activity. I'm not sure if I can extend it to the equipment, but for this reason I have my Patreon donations and supporters, so big thanks to them, and this equipment I bought from their donations. I will start with this pressure sensor, it will be faster. This is the user manual, some equipment. It has its own battery and this is the adapter. Now in my case they sent me with the wrong plug, this is not the AC plug for the EU, and I will get some refund probably, we will see soon. Let's turn it on. Very first thing you want to do with it is to disable that annoying beep sound of the key. Let me show you. Enter, this is the default password. Enter. System setup. Enable key beep, it's disabled already, let me show you. This is extremely annoying. There are different modes. This is the graph display with some timeline. It's a bar. And now we have the number. One is the current value and this is the peak, and this is the mode I will use because it is the most visible one. Just one demonstration. Peak 24 kilograms. And now let's check this 1-ton Arbor press. Nice packaging. Well, it requires some minimal assembling, but much longer time will be the cleaning because it is fully covered with this protection grease, and I will clean it with the WD-40, but don't worry, off camera, and later I will place some grease where it is really needed. I bought this version with this wheel. For faster adjusting. And when I need the force, I'm using this arm. It arrives with this rotary stand, but I don't really plan to use it, but still I need to clean it a little bit. I will use a flat plate here. About this rack gear, if it wobbles, then, oh, it needs some cleaning too. If it wobbles, then we have to tighten these bolts, but just very gently. First, I have to untie this locking. I need a 10mm opponent wrench. Then tied these almost with my hand only. And it's not wobbling anymore, I'm tightening their position. And same in this direction too. We have 2 bolts here. But it's fine. This pressing element already have the hole from the bottom, and it arrives with these 3 inserts. I need something like this with the flat surface, but this is too small. And when it is in, I can lock it with the bolt from this side. So I need something bigger, and maybe I will make it from this. I thought this will be enough. This is M24, but I want a little bit bigger. This diameter is a little bit small for my taste, so probably I will use M30. Currently I don't have one. I will just make this cylinder, and this side should be approximately 10mm because that's the size of the hole, and this is in the minus, in this case 9.8mm approximately. Now there is one very annoying problem with these presses. Let me demonstrate you. Let's say I want to press something on this height. In this case it's perfect. I can push a lot of force here with my arm. It is in perfect position. But let's say if it is something much smaller, in this case I ended in very uncomfortable position of this arm. If it is not locked down to the desk, I cannot even pull it. There are several solutions to this problem, and I can see a very common solution on the internet is that removing of these two teeth, last two. And with this, when I'm in upper position, that rotating part will skip over this, and we can adjust very quickly the position of this arm. Now my problem with that solution is that we are reducing the maximal height. I mean, this is quite small press, and I can imagine the situation when I will run out from the space quite quickly, because it will skip approximately over here, and I'm reducing this by, let's say, 10-15 millimeters. So I think my solution will be removing one tooth, and maybe I will go deeper in this flat part. I want to print one for the testing, but I need to know the modulus, and I'm measuring the pitch. Okay, this is 8 teeth, 62.8 millimeters. 62.8 divided by 8 is 7.85 millimeters, that's the pitch. And if I divide this with the pi, in that case I'm getting approximately 2.5, and this is the modulus. And for me this data is enough, and I can design some in Fusion 360. Of course I need some other dimensions too. The cross section is square, 24.5 millimeters. And the distance from the first tooth and edge is 39 millimeters. And this is my plan. I want to remove one tooth and approximately 6 or 7 millimeters in that flat surface. This should work. I'm not sure is it enough, but let's try it. I was curious how does it look like from the inside, and I don't really like that these bolts are ribbing directly against this surface. I mean, some kind of plate or something should be added here. Maybe the solution could be that I will add something to the end of these bolts. And I can even install this plate back, because now the tools are going until the end and I can slide in from the bottom. So this is how it looks like if I remove this one tooth and approximately 7 millimeters from this surface. I was thinking to go down actually completely into this flat surface, but don't forget we have this hole, and I still want to have some materials above the end of the hole. Okay, the metallic plate is heavier, so it has some gravity, but here I will just press it down. Okay. It jumps over here, so maybe I lost 3 or 4 millimeters in total height, which is completely acceptable. By the way, I know I have a dirty imagination. I'm thinking at what load will it break? I know, maybe I should test different materials. What do you think? Would you like to see that kind of video? Let's start with the milling. First I'm removing one tooth, and later that flat surface. This is the end operation, sharpening the edge a little bit. And it looks promising so far. Working on the edge a little bit with the file tool. And now I'm using that M24 bolt, just to make some kind of disc press. For this I needed approximately 1 hour. Chamfering the edge for the end. And it's done. Looks promising, but it's time to test it. Fit perfectly, and looks like this size is good enough. I don't even need bigger. It's time to test it. Perfect. Quick demonstration. It's in very bad angle. And now perfect. In the meantime I printed these small plates, so it will protect a little bit better the surface from these bolts. And this one goes here. And the distance between two bolts, 39.5 and 24.3 millimeters in my case, but I have the feeling that they will vary it from the product to product. And now it's completely ready for the testing, and I need some test objects. I'm printing these parts from the PLA. It's metallic color PLA or something like that. It's time to break some plastic, but I'm not sure what will be the behavior of the material, so I'm wearing a face shield. This is my first attempt, which I couldn't really finish. Looks like it has to be secured during the testing. I didn't expect so big loads here. And this bolt will be replaced with a set screw, because currently I cannot do the adjusting. 1-inch cube, testing in X direction. 1-inch octagon base, also in X direction. Same size object, but now testing in XY direction under 45-degree angle. Ooh. Again 1-inch cube, but in Z direction. No way. Wow, for the Z direction I need something smaller. Any suggestions? But let's do some conclusions now. Actually, one more thing I want to test to see how this graph looks like. It's really nice, but too small for the camera. Peak 313. So what is your opinion about my new test equipment? And one of the first videos will be testing different infill types, but not only in X direction, but also in XY under 45-degree angle, but also in Z direction too. And I'm curious, what is the typical percentage you are using for technical parts? 30, 40, 50%? Later I want to test different infill percentage too, but after I know which is my favorite infill type. And I'm quite sure that in the near future I will test this 3D printed rack gear too. I'm just very curious when will it break, and I don't know, I'm waiting suggestions for the materials. And again, huge thanks to the Polymaker and to all my Patreon supporters, because their donations makes this kind of videos possible. And to all you others, well, thank you for watching this video to the end, and happy printing!